Previously on Chemistry Z, our heroes journeyed to the reactive realm of Group 7 elements. They also mustered up the willpower to deep just how displacement reactions occur. Then they were caught off guard by onslaughts of word and symbol equations. But after the secret wisdom from the ancient specification, they understood how to defeat these foes. But now, our heroes must level up in order to tackle the different types of chemical bonds, and so they will investigate the different states of matter. Will they be able to pattern the knowledge? Find out in today's episode of Chemistry Z. Here are the retrieval questions for this lesson. You know what to do. Fluorine is more reactive than bromine. The electronic structure of fluorine is 2,7 and bromine has 45 neutrons. Here is where I have to reason with you all. You've all been lied to, and I'm going to lie to you now.
He lied!
Our universe is so much more than we can fathom. About 3/4 of it is something called dark energy, and almost all of the rest is dark matter. And you see that small slice of stuff there? That is everything we can interact with. All the galaxies, stars, planets, pancakes, everything. This blew my mind when I first found this out.
Oh, Jesus! Joseph!
And even within that thin slice, a state of matter that you're not supposed to know for GCSE is actually the most common one. And that is called plasma. It's what you find in lightning, fluorescent lights, and nuclear explosions. But as I said, for GCSE, you only need to know 3 particular states. And of course, the 3 states that you need to know are solids, liquids, and gases. You lot may think you've got these drawings on lock, but every single year, about 80% of students always flop at least one of these. Solids should be in a regular arrangement with the particles touching each other.
I'm not touching you.
She's touching me. She's touching me.
I'm not touching you.
You're touching me!
Not.
The particles in solids are also vibrating in a fixed position, so they're not moving around, but they're just jiggling in one spot. Liquids is where most people flop. You shouldn't draw large gaps between the particles. All of them are still touching like solids, but they're not in a regular arrangement. They're all close to each other.
Baby, come closer.
These particles slide over each other randomly. Now, everyone and their grandmother knows how to draw gases. Just a few atoms here and there, and they all move rapidly in all directions. I've got these 2 challenge questions now. Which of these have the least amount of energy, and what type of energy are we talking about? Solids have the least amount of energy, gases have the most amount of energy. And because it's movement, the type of energy is kinetic energy, which is the same as saying movement energy. You also need to know the limitations of this model of the states of matter. We covered the different atomic models in detail in this lesson. Click it to click that video to be transported over there. The first limitation is that atoms are not solid spheres. Remember, J.J. Thomson and Rutherford deaded that idea. Also, the forces between the atoms are not accounted for, so we can't really get a sense of the forces attracting them. You also need to know the names of the processes that turns one state of matter into another. Here are the different directions and the names of each.
Make sure you don't copy from each other, because if you do, I will know. Eh? I'll be back very soon.
You know what to do now. A is showing a liquid turning into a gas, so that is boiling / vaporization. B is showing a gas turning into a liquid, so that's condensation. C is showing a liquid turning into a solid, so that's freezing. D is showing a solid turning into a liquid, so that's melting. E is showing a solid to a gas. This has a special name and is sublimation. That means that the last one, a gas turning into a solid, is deposition. The last thing we have to look at is the heat curve of a substance.
What is this one again? Johnson, so what is this one again?
It really isn't that deep, to be honest. It's just a graph that shows the temperature of a substance as we heat it over a period of time. Here is the line that we should expect. We expect that the longer we heat it, the higher the temperature gets. But this is a lie. It doesn't do this.
It was all a lie. Guys, it was all a lie. She lied.
This is actually what happens. When we heat a solid, the particles gain more kinetic energy and vibrate more. This is what an increase in temperature actually is in terms of particles. The particles just move around more. Then when we get to the melting point, the energy no longer goes into making the particles move. So the temperature doesn't go up. Instead, the energy from the surrounding goes into breaking the weak intermolecular forces keeping that solid structure together. We call this energy needed to break these forces the latent heat of fusion. The solid then turns into a liquid and it heats up as you expect. But then again, the temperature does not increase as you get to that boiling point. That is because the energy from the surrounding is going into breaking the intermolecular forces holding the liquid together. And after it's all boiled away, the gas increases in its temperature by moving around even more. Okay, so let's quickly recap that.
But I'm dead. No, don't! Leave me alone, I'm dead. No, you will not die.
Listen. As a solid, the temperature increases because the particles are vibrating more. Then at the melting point, the temperature stops going up because the energy from the surroundings, that latent heat of fusion, is used to break the intermolecular forces. This melts the solid. Then the liquid heats up onto the boiling point. The energy from the surrounding then goes into freeing up the particles and they vaporize into a gas.
I'm dead.
What is it?
Oh, Auntie, please, you are dying. Help tell Papa that we have tried though.
Yes. It's okay. The lesson is done. Check the description to check my free flashcards and revision timetable, and also skip to the parts of the lesson you want to go and redo using the timestamps, and I'll catch you guys in a bit.